Alright, this is interpreting key features of linear functions. So the essential question, how do I identify and interpret key features of linear functions from a graph? Okay, so let's first talk about the x and y-intercepts. So the y-intercept is when x equals 0 and usually represents when something is starting. Okay, so like the beginning amount, the starting height, the starting distance, your initial value. Okay, so that's your y-intercept is what you start with. So if it says anything like that, like you start with this, you start here, you begin with, your initial value is, that is your y-intercept. Okay, the x-intercept is just the opposite. It is when y equals 0 and usually represents when something is finished. Not always, but finished like it's empty. So if you're draining a pool, the x-intercept would be when the pool is out of water. When something's on the ground, so if you throw a football, your x-intercept would be when the football hits the ground, something like that. Okay, that's usually, again, it's not always, but usually that's what it's talking about when you have word problems. Okay, domain and range. For real-world situations, which is today, the domain and range almost always starts with 0. Okay, again, I'm not going to say always because that's not always true. But almost always, a lot of times, you'll start with 0 for both. Okay, and so the domain will usually start with 0 and end with the x-intercept if you have one. The range usually starts with 0 and ends with the y-intercept. Okay, again, it depends on the graph. There are some that don't necessarily start with 0, end in y-intercept, or start with 0, end in x. Sometimes they start with the y-intercept and end on a different number that's bigger. But a lot of times this is what you end up with. Okay, so let's do the example below. So we want to identify and interpret the key features for each situation, which there's only one. Okay, so Sam started 9 feet away from a motion detector and walked toward the motion detector at a speed of 15 feet per second. Graph Sam's distance from the motion detector as a function of time, and then identify key features of this linear function. So first you need to go through and figure out what is x, what is y, to label the axis. So if you look over here on the graph, x represents what? Y represents what? Okay, so first we go back through, and if we read, you want to look for where it tells you that something is a function of something else. Okay, so right here where it says graph Sam's distance from the motion detector as a function of time. Okay, anytime you see the function of, and then something, function of time, that is going to be your x. Okay, so function of time is x. So we can go over here, and x represents time. Okay, now what comes right before function is y. So Sam's distance from the motion detector, it would be y. Okay, so this is y right here. So where it says y represents, we're going to write distance. So y represents distance, x represents time. Because typically, you always say that you have y as a function of x. Okay, so the y comes first, the function of is always x. So now let's figure out what time that I have. Well, it doesn't really give me a time. Okay, it gives me 2 other numbers though. So the first one is, let's look at the first sentence. Sam started 9 feet away. Okay, so that's important to know. I started 9 feet away. So if we're talking about our starting value, our initial value, right? If we go back up here, the starting value, or the beginning, right? Starting is the y-intercept when x equals 0. So if I start 9 feet away, I'm going to go up on the y-axis to 9, and I'm going to put a point. So that's my starting point. I started 9 feet away. Okay. Now we have to go and read to find what this other number means. Okay, so I start 9 feet away from a motion detector. I'm walking toward the motion detector at a speed. Okay, so I'm walking toward the motion detector at a speed of 1.5 feet per second. Okay, so if I'm walking towards something, I'm 9 feet away. If I'm walking towards something, my distance, my y, should get smaller as I get towards it, right? So that means I'm going to be going down 1.5 feet per second. Okay, so our distance, that's 9 feet, 8 feet, 7 feet, 6 feet, so on. And then our time, these can be seconds. 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. So starting with 9, if I'm walking towards it, my number should go down 1.5 feet for every second. So I start at 9 feet. I'm going down 1.5 feet for 1 second. Then I go down another 1.5 feet for another second. And I keep going. 1.5, 1 second. 1.5, 1 second. 1.5, 1 second. And then last, 1.5, 1 second. Okay, so I've plotted all my points. Now, I've plotted all the points that I can plot easily. Because as you know with time doesn't just jump from 1 second to this next. So if I have something like time is always going to be continuous. So I'm going to connect these two dots. Well, more than one, but I'm connecting my beginning and my end, okay, and all the points in between. So now I have a continuous function. Okay, now let's go start answering these questions. First one, appears the x-intercept. Well, if I'm on the x-axis, my graph hits the x-axis at 6. Okay, so my x, or my x-intercept, would be 6, 0. And then my y-intercept is on my y-axis, is 9. So this would be 0, 9. Okay. So if you remember with intercepts, my x-intercept is always x comma 0, and then my y-intercept is always 0, y. All right, so we have our graph, we have our x-intercept, our y-intercept. Now we can answer the questions at the bottom. Okay, so the x-intercept means, well, let's look at the graph. My x-intercept we know is 6, right? 6, 0. So if this is seconds and this is distance, if I'm starting 9 feet away, I'm walking towards my motion detector. At 6 seconds, I'm now 0 feet away, so I've reached the motion detector. Okay, so the x-intercept means that after 6 seconds, I have reached the motion detector. Okay, so that's what we're going to write. After 6 seconds, Sam, because that's who we're talking about, Sam reaches the motion detector. Okay? Because if I'm 0 feet away, that means I've hit it, like I've run into it. Okay? So after 6 seconds, I'm at the motion detector. Okay, the next one, y-intercept. Well, my y-intercept is up here. That's 9, right? So this is 9 feet, because we're talking about distance. So I have 9 feet is where I start from the motion detector, because that's what it tells me in the sentence. Okay, so the y-intercept is how far away I started, right? Started from the motion detector. So the y-intercept means that Sam started 9 feet from the motion detector. Oops. Because remember, your y-intercept is always your starting value or your beginning. So I'm starting 9 feet away. All right, the next one. For this situation, the graph is continuous or discrete. Okay, so if I look at this, this is a line, and we know that lines are continuous. So anytime you talk about time, so anytime that there's time involved, time is continuous. Because again, time doesn't skip. I can't go from 1 minute to the next and nothing in between. All right, that'd be really weird. All right, last two, domain and range. So domain, remember your domain is x, okay? So domain is x. So I go find my left side. So here's, if I go up this line all the way to the left, here's my left boundary. And then I go all the way, here's my right boundary. Okay, so then you look at what two numbers that I go in between. Well, I started with 0 and I ended with 6. And there's no open circles on this line, so I would have 0 less than or equal to x less than or equal to 6. Because I went from left to right. Okay, last one is the range. So remember, range is y. So now I look at my graph and I look at the y-axis values. What's my lowest? If I go all the way down this line and go over, my lowest y is 0. And I go up the line, and then my highest y is 9. Okay, so my lowest is 0, my highest is 9. I'm on the y-axis. And there's no open circles again. So my range would be 0 less than or equal to y less than or equal to 9. And that's how you interpret key features of a linear function.